All right, welcome everybody, the online people and the visitors in the center. We're about to hear a man whose name has been attached to a spot on Jupiter. Not many of us can say that, so it should be a very interesting talk, and we look forward to it, Clyde. Obviously not just about that, but a whole lot of other questions that Pierre asked you in his email about what you're doing in Namibia and so on. So we look forward to hearing all that. And over to you, Clyde.
Thanks, Derek. And firstly, a big thank you to you and Pierre for the invitation to talk this afternoon. It's always a pleasure to share my experiences with you guys. And I hope everyone will find it of interest. So I must admit, as an amateur astronomer, I had no expectations. I think my journey followed very similar to many of us, where I spent many hours under the sky observing star clusters and nebula, and from time to time looking at the moon and the planets. But my journey actually goes many years back when I undertook a school project in the late 1960s, and obviously the time of Apollo, and my interest was certainly triggered at that point in time, and I spent quite a lot of time doing the project. The teachers up in Scotland were on strike at the time, and whereas we had to do one project book, I actually ended up completing 5 project books. But my interest during that time swung a little bit from space travel and obviously Apollo and the moon to a much broader interest in astronomy. And while we were tidying up all our stuff in preparation for our move to Namibia in 2022, I was delighted to actually find this book that had come with my very first telescope when my dad bought me my first telescope in 1969. And it was quite interesting to see that there were a few calculations in the back cover, bearing in mind that I was like 10, 11 years at the time, some RA and declination calculations. But that book now sits proudly on my bookshelf. And then life would continue, and I actually, the family emigrated to South Africa in 1970 to Durban, and my mom and dad supported my astronomy as a hobby. And through my life, I actually graduated as a chemical engineer, and that put me in a position financially where, although I didn't necessarily have the time due to work and family commitments, I was able to slowly get better and better telescopes. But there was a milestone moment really in 2014 where rather recklessly I invested in this telescope. At this point in time, I'd built myself a fairly basic back garden observatory, although it did have a motorized roof on it. And at that time, I had a 12-inch Meade. But I was aware of the 14-inch Celestron that was in the country. And I was also aware that the Rand dollar was not looking particularly healthy at that stage. And although I was paying off two properties at the time and putting my 2 kids through their degrees, I actually took the step and invested in this telescope. And I often look back at this photograph and smile, pretty much knowing that at that point in time, I had no idea what lay ahead of me in the years ahead. But it was a step that I took, and I can quite honestly say it was one of the better decisions I've taken in life. So having the C14 in the observatory, obviously very bright sky conditions in Centurion, Pretoria, between Johannesburg and Pretoria. my attention was pretty much drawn towards planetary imaging, purely because of the light pollution, and more specifically, the brighter planets. And I went on a bit of a program of pretty much educating myself, and I spent a lot of time and effort learning the techniques, exploring the different methodologies that the leading planetary imagers were using at the time. And of course, slowly getting better and better cameras. And during that first couple of years, there were two key realizations that I really came to. Firstly, as I opened up communication with others, I discovered this wonderful community of planetary imagers that exists around the world. People are dedicated and pretty much out there on a regular basis capturing planetary images. And then the second one, which really caught my attention, was the level of collaboration that was taking between the leading amateur planetary imagers and the professional science community. And at the time that I installed the telescope, Mars was just past opposition, but it was the best placed planet for me to really test my skills on and develop my skills. And I was out there pretty much on every possible occasion that I could. And during that time, I started submitting my images to the international databases. And I very quickly built a positive relationship with Dr. Richard McKim of the British Astronomical Association Mars section. And in fact, it wasn't long before I picked up this series of images in June. And what was interesting was that the seasons on Mars were not susceptible to dust storms. But from one night to the next, I picked up this fairly bright feature close to the famous Syrtis Major. And I quickly sent a very quickly processed image through to Richard. And I was quite surprised or taken aback when a few hours later, he actually put out a global alert indicating that it was a dust storm and requesting that observers around the world try and track this. One of the nice aspects of Mars is, with its day being very similar to Earth, within about 15 minutes, you get this very gradual rotation over a period of a few days. So you're actually able to track any features that are that develop. And I was able to track this storm from its initial initiation, and then as it expanded and then eventually dissipated, which is very much a classical process for these fairly localized dust storms on Mars. A few months after, I was obviously developing a little bit of a reputation for my specialization in Mars at the time, although I was starting to image the other planets. I was approached by Lyrica at NASA to handle a SABC interview on the Schiaparelli probe. Now, this was going to be live, and I must admit, I was not at all comfortable, but we went through the process. I asked the producer for a few questions, hopefully that I could prepare for. And of course, when the day came, the first question that that Renee Vest threw at me had nothing to do with any of the questions that that had been given to me. So from the first minute, I knew that I was flying by the seat of my pants. But obviously, an exciting, although rather stressful experience. But thankfully, it went fairly well. I think I can just take on a couple of comments. I took my Mars globe with me just for a little bit of a confidence booster, and I think it worked well. And then as I left the studio to go back to the waiting room, I passed Julius Malema and his entourage, and he had a little bit of a inquisitive look at the globe. And when I was back in the waiting room, I was actually watching the continuation of the program. And after my interview, which went on for about 10 minutes, they had a professor from one of the universities, and they were talking about the philosophy and religion of people going to Mars and how it would impact them. And to my horror, he pretty much froze on set, and the presenters had to dig him out of a hole a little bit. But it just shows that these type of things can happen, and I don't think in any of my live TV interviews have I felt particularly comfortable. And of course, I just continue to image Mars. On the next opposition, I was blown away with obviously the level of detail that we're able to get with the imaging techniques that we have. And you're able to pick up, here's Syrtis Major, and you can see dust being blown out of the huge Hellas impact basin. You've got the cloud formations that you can seeing develop. And then in terms of the Tharsis, the huge volcano or volcanic region, Tharsis, where you've got Olympus Mons, and then the three Tharsis Montes, you get the orographic clouds that you're able to follow as well. But all of this work that I did on Mars would lead to an absolute game-changing experience for me, where in 2017, I was invited to the European Planetary Science Congress by Marc Delcroix from France. He's down at the bottom right here, very strongly involved in the Pro-Am community. And I gave a presentation on my Mars images from over the period 2015 to 2017. But what I do need to say is that the afternoon I arrived in Riga, Latvia, which is where it was being held. And I need to say, in terms as an amateur astronomer, all my costs were covered for this conference. The afternoon that I arrived at the hotel, I sat down with Dr. John Rogers of the British Astronomical Association Jupiter section, who I'd met previously in London. But it was also a privilege to meet Dr. Glenn Orton of JPL, NASA, who works on the NASA Juno mission, but who has also been involved in virtually all of the NASA spacecraft missions to the gas giant planets. So we were sitting having a few drinks at this very moment, and then we were joined by another gentleman, and we were introduced, and John and Glenn obviously knew this chap very well. But as I was introduced to him, he shook my hand very warmly, and he said, "Wow, you're Clyde from South Africa." And I wasn't quite sure how to handle that, but I said yes. And he said, "Clyde, I just want to say it's an absolute pleasure to meet you, and I want to thank you for the wonderful contribution that you're making." Now, I didn't know who this chap was, but the moment that I had a gap, I'd been given his name, so I quickly went and Googled him. And this was Dr. Lee Fletcher down at the bottom here, who is pretty much the leading specialist in the atmospheric phenomena of the gas giant planets. And at that moment in time, when I realized how he had introduced himself to me and how he had approached me, it was an absolute moment in time. I was of the opinion that here's me enjoying myself in my little back garden observatory, getting excited about seeing the planets every night. And yet it went way, way, way beyond that. One of the other people that I was fascinated to meet at that conference in Riga was Dr. Michael Ravine of Mellon Space Science Systems. Now, Mellon Space Science Systems are responsible for producing cameras for many of the NASA spacecraft on their planetary missions. They've got cameras on board Curiosity and Perseverance rovers on Mars. But yeah, we had a very good chat about, because I was referring quite often to the Mars Reconnaissance Orbiter images that they put up on a regular basis. Mellon Space Science Systems are, they supplied the wide field camera for the MRO, but they also are responsible for downloading and processing the data from the orbiter. So he introduced me to Dr. Bruce Cantor, who is the planetary scientist who actually processes the images from the orbiter. And just as one example of the interaction that I've had with them was that in April 2018, I captured this image. And you can see this feature near the terminator, and I had rather blandly, when I circulated my image in the morning, commented that, oh, and we can see Olympus Mons coming into view. Now, during the course of the morning, I just had a strange feeling that it just didn't seem to be in the right place. And I actually sent my image through to Bruce at Mellon Space Science Systems. And that same afternoon, he sent me the images from the MRO that had been taken also that morning. And it had picked up this feature exactly where I had picked up mine. You've got the Elysium volcanic region here, and Propontis, this dark region here. But the spacecraft had also picked up this feature, and more exciting for me was that he actually sent me an image from the high-res camera on Mars Reconnaissance Orbiter, which actually showed the dust storm, very typical of a localized dust storm on Mars, and typically it wouldn't even last a day. But what was amazing, if you look at some of these small light spots in this high-resolution image, you can see there's a dark feature next to them. And these are actually these extremely high dust devils that we get on Mars, which are on the edge of this dust storm. And that's the shadow from these impressive dust devils. And you can in fact see the lava flows from Olympus Mons here on the right. One of the other spacecraft missions that I've been involved with is the European Space Agency Mars Express Orbiter. And specifically, the lead planetary scientist on that mission is Professor Agustin Sanchez La Vega, who I also developed a very close relationship with. And just out of interest, the Express Orbiter is taken some wonderful images of the linear cloud, which at specific seasons extends from Arsha Mons, one of the large Tharsis volcanoes. And in fact, I, using a blue filter, have managed to capture one of the very, very few Earth-based images of the Arsha Mons linear cloud. During this period, over the next couple of years, I found myself in a few more TV interviews, this time with ENCA. As I say, I don't think they ever became easier. I've done a number of interviews which were stress out of the situation, but still exciting to be involved in these events. I just wanted to share this. Obviously a double set of images, one from near opposition, Mars 2016, and one from 2018. And in fact, they show very much the same view of the Sinus Meridiani and Sinus Sabius. But in 2016, the atmosphere was relatively clear. In 2018, we had a global dust storm, and you can see Sinus Sabius down here. Sinus Meridiani is almost totally covered. The reason I've shown two sets of images is that the images on the left are from Hubble Space Telescope, so this one, and the two on the right are images that I captured, and it's obviously a fun exercise to do to compare what you're able to capture with Hubble. Just out of interest, I've put a picture of Opportunity rover down there, and due to the fact that Opportunity operated only on solar panels, unfortunately the rover was lost during this global dust storm of 2018, and they were unable to recover. 2019 would bring some remarkable developments on Jupiter related to the Great Red Spot. Now, the Great Red Spot is well documented that particularly over the last 100 years has been reducing in size quite dramatically. Currently, about you can fit one Earth diameter into the Great Red Spot as it is now. But in the early 1900s, you could pretty much get 3 Earths across the Great Red Spot. But in 2019, we had these remarkable flakes being produced off the Great Red Spot. And if you look at this little cyclonic storm here, these move along this belt from the east and then move into the Great Red Spot hollow. And it was actually found out that these were responsible for triggering these flaking events. If you look at the Alpo Japan database that year, pretty much from March through to October, my alarm clock was being set on the transit of the Great Red Spot. I covered these events extensively for the amateur community, and I was able to attend the European Planetary Science Congress in Geneva that year, and I presented a paper on the flaking events of the Great Red Spot. The events were also captured in a peer-reviewed paper which was published, and I was fortunate to be included as a co-author on that paper. And then further developments on Jupiter would follow quite dramatically. You may be aware that the Juno, NASA Juno spacecraft is in orbit around Jupiter currently, launched in 2011 and arrived in 2016, put into extended 53-day elongated orbits. And you can see that during the close approaches, which are called the perijoves, the spacecraft flies in very, very close over the cloud tops of Jupiter, approximately, on average, say about 4,000 kilometers above the cloud tops. And of course, during that flyby, the spacecraft is capturing extremely close-up images of the planet. And the mission team had come out to the amateur imaging community to request support. So basically what they were asking was that in the few days before and after each period of flyby, if the amateur community could produce global images of the planet, and specifically over the track where the spacecraft would fly, which would then be used to put the close-up images in context. And over the few international conferences that I attended, I was very privileged to develop a relationship with the Juno mission team. Glenn, of course, I'd had extensive interaction with before, but it was a privilege to meet Scott Bolton, who's the PI or lead scientist on the Juno mission, and also Candy Hansen, who's the co-lead, and she's also responsible for the imaging programming of the Juno spacecraft. And on the back of the support that I was giving the Juno mission, I was actually invited to a workshop in London at the Royal Astronomical Society, where a relatively small number of the leading planetary imagers were invited, together with a whole bunch of professional planetary scientists associated with the Juno mission. And it was a real privilege to meet guys like Anthony Wesley, planetary imager from Australia, Chris Goh, who's very well known, and an amazing experience to meet the planetary scientists involved with the mission. Just out of interest, we were given a private tour. This is actually the death mask of Sir Isaac Newton, which they pulled out specifically for us to have a look at. Now, the way that the support worked for the Juno mission is that we would take images of the planet, and these would be rolled out into a global map of Jupiter, and the path of the Juno spacecraft would then be laid across. And the intent would be that if there's anything interesting in the region of the track, that the mission team would specifically manage the imaging program on the spacecraft to try and capture those interesting developments. And as it was, on the 31st of May, this was approaching the PJ27 flyby. I had set my alarm for the early hours of the morning, and I typically capture RGB data, and then infrared, and then methane band, which is at 890 nanometer. And I'd run through my imaging captures in color and infrared, and didn't see anything particularly interesting. Just out of interest, the spacecraft track is indicated down at the bottom there. But when I started imaging in methane, I saw, this is the great red spot, by the way, this large bright one, and one of the standard ovals on Jupiter. But this bright spot was very, very evident in methane wavelength. And I initially thought that I'd captured an asteroid impact. But obviously, over a time period, the spot remained, and I was quite stunned. Now, a close friend of mine in Australia, Andy Casely, he had been imaging 10 hours earlier, and he quickly put together this GIF animation, and you can see that 10 hours earlier there was nothing there, and then I had captured the spot appearing. Now, in methane wavelength, bright features are indicative of being high in the atmosphere. So, for example, the upper clouds of the great red spot extend to a high altitude. So this was an indication of a storm system that had developed within those 10 hours and had blown or erupted a plume into the upper atmosphere. I obviously reported this immediately to the Juno team, who were extremely excited about the development. And 2 days later, the Juno spacecraft flew in over this region, not directly, but because they were aware of where the storm was, they were able to time the imaging to be able to capture this region. And we got these beautiful views of the cyclonic storm system that had developed. And this is a more global view as the spacecraft was leaving the planet to go out into its elliptical orbit. Now, over the following month, I was aware that after each perijove flyby, the Juno team puts out a press release, typically showing images of a number of interesting features during that flyby. And I was obviously hopeful that what is now become known as Clyde spot, both in the amateur and planetary and professional community. The initial outbreak storm is now being called Clyde spot. I was hoping that it would get a mention in the press release, and we had communication on and off during the few weeks. But of course, I was totally stunned when the press release for the PJ-27 flyby came out, and there was only one feature on it, and that was Clyde spot. So that was just another mind-blowing experience for me. The Juno team went pretty crazy on the feature, going out on Instagram, Facebook, YouTube, and they really made a big song and dance about it, which I obviously was extremely appreciative of. And from there, it just spun out into the general media, a lot of publicity around it, which I certainly appreciated. An interesting one was that carte blanche actually came around. Derek Watts came around to the house to do an interview for the Mars 2020 mission, the Perseverance rover and the helicopter. But during the time that he was there, we got talking about Clyde spot as well. And although the final carte blanche segment was meant to be on the Perseverance rover and helicopter, he snuck in quite a nice section on Clyde spot as well, which was awesome. And of course, it was tragic that we lost Derek. I think it was last year. I certainly appreciated the time that I managed to spend with him. It would take about a year because the Juno spacecraft doesn't fly over the same region of Jupiter every orbit. It took close to a year before the spacecraft was able to fly over the region of Clyde spot again. And of course, I'd been extensively following the development of the feature. It wasn't particularly impressive because Jupiter wasn't particularly well placed, but we still tracked it nonetheless. But again, the spacecraft came up with these amazing images, close-up images, showing that the spot had developed from a cyclonic storm into what we call a folded filamentary region, a highly turbulent feature on Jupiter. And again, I was extremely delighted when NASA came out with the follow-up press release on PJ-33. Again, pretty much concentrating on Juno returning to Clyde spot. One of the really wonderful things for me was that the Planetary Science Group at the University of Bilbao, and I've mentioned Professor Agustin Sanchez La Vega previously, but Ricardo Hueso has also become a very good friend of mine. And one of his PhD students actually researched Clyde spot for the first year and a half of the developments. And they actually published 2 peer-reviewed papers in the Icarus journal. And to be honest, I had expected during the peer review process that the term Clyde spot would be tossed out and replaced with something like the South Temperate Belt convective storm development, something like that. But I was delighted when the term Clyde spot was retained in the papers. And obviously it's a little bit of a legacy for me personally. And I can assure you my 2 youngsters got good mileage out of it with their friends. Just out of interest, what happened with Clyde spot, it actually eventually, or let me just say that the term Clyde spot refers to the initial storm system that developed. But if you look to the lower left of the Great Red Spot here, you can see this dark train. And this has now become segment G of the South Temperate Belt. And this has continued to expand and is still visible today. And it's still quite impressive. So it's amazing to think that with so many smaller storm systems on Jupiter, because of the turbulence, that they literally dissipate within either a few weeks or a month or a year, that this specific storm system has continued to develop into this dark segment on Jupiter. And of course, one of the other planets that I've spent extensive time on is Saturn. Obviously, an absolutely beautiful sight under all conditions. The rings are fairly edge on at the moment, which takes away a little bit of the beauty of the planet, but still fascinating. But the colors on Saturn, it's probably the most diversely colored planet that I image, and it's just stunning. But over and above that, we're obviously doing collaboration work with the planetary scientists. Particularly interesting one is this is obviously a spacecraft image from Cassini, if I can recall. But you've got this amazing hexagonal jet stream around the North Polar Cap, which can be identified and observed in amateur images. And I've been fortunate to be included in also research papers on Saturn. As we were packing for Namibia in 2020, it came as quite a surprise for me. I had obviously been delighted to be recognized by NASA in terms of the President's Award and also the Overbeek Medal based on the work that I'd done. But 2022 was a year when I was particularly unproductive, purely because we were preparing for the Namibia move. And in the space of a month, obviously based on the previous work that I'd done, I was delighted to be awarded the Stevenson Award by the British Astronomical Association, and within a month, the Walter H. Haas Observers Award from the Association of Lunar and Planetary Observers in America. And again, this is not why I personally do it. To get the recognition is wonderful. But I can maybe click back to my experiences at the conferences in Europe, where, number one, my enjoyment comes out of being out in the observatory and those planets coming on the screen and me seeing what is happening on each of those planets in real time. But also, I've had the experience where at those conferences, I've had leading planetary scientists come up to me, pat me on the back and say, "Clyde, I just want to say you're doing an amazing job." And irrespective of the media, and certainly I appreciate it, and similarly with the awards, which I greatly appreciate. But to know that you're making some form of contribution, which is recognized and appreciated by the professional planetary science community is just amazing for me personally. One rather amusing spin-off from the Stevenson Award, the British Astronomical Association, was that the South African media, and more specifically the Afrikaans media, really picked up on this. I had them come around for an interview at the house, but I made front page of the Beeld along with the Guptas of all people, which was quite something. But again, I appreciated the Afrikaans media running with the story. For quite a number of years, as my passion for planetary imaging improved, I realized that I was on a little bit of a plateau with us being in Pretoria, and I did quite a lot of research on alternative options. Myself and Marina, my wife, spent time going down into Karoo, more specifically Victoria West, Loxton, Carnarvon, and we obviously looked at Sutherland. But I'd picked up from research that the Gamsberg region of Namibia on the inland plateau had quite a reputation for astronomical conditions. And we were introduced to a farmer in the region, and we made an instant connection. We made a couple of trips up to Namibia to visit, and he very kindly offered us a place where we could move into on his farm. And we applied for our permanent residence, which was initially declined, and we went through a repeat submission 6 months later, and we were finally accepted. And in October 2022, we moved onto the farm close to Gamsberg. We're about 30 kilometers away from the Gamsberg. We were doing some small renovations on the place that we were going to move into. But so for about 4 months, I stayed in the main farmhouse, and of course, I couldn't live without my imaging, so I set up a very temporary arrangement in the garden and managed to continue. But of course, once we had settled it was high priority. I dismantled the observatory in Centurion and shipped it up in the container. And over the period from January 2023, we basically leveled off a bit of a raised area, and we started re-erecting. The initial objective was just to rebuild the observatory as it had been in Centurion, although you can see that what I did do was to actually put additional sheeting on the outside, primarily because of the strong winds that we have here and the weather conditions. So it gave me a double wall system. But April 2023, the observatory was up and running as it was in Centurion. And I think this is one of my earliest images of Saturn from the new observatory. Of course, we weren't done, and it always been a dream for me to have a little bit more of a comfortable setup for my planetary imaging. So we extended from the original observatory with a small control room, put in a ceiling, and June 2023, the observatory was pretty much set up and fully operational. And yeah, on pretty much every clear night where there's planets visible, this is where I'm spending my time. Just an amazing place to be, and very much a happy place for me. The control room has developed since then, and you can see that it's been breeding screens. I've recently just mounted the weather station readout up on the wall here, and I've also just recently put in a sky camera for monitoring sky conditions. But very comfortable. I've got a little coffee station, and as I say, very much a happy place. But a very recent development has been that I've gone a little bit back to my amateur astronomy roots. We obviously in a Bortle 1 location here, that's the skies are just absolutely stunning. We've got a little bit of sky glow from Windhoek, 100 kilometers away, and from Rehoboth to the east, 80 kilometers away, but still absolutely pristine sky conditions. And what I've done over the last couple of months, I actually took down these alien invasion trees, and we developed a stargazing platform just adjacent to the observatory where I've been running some stargazing evenings. And we had a recent visitor from Germany doing astrophotography there. But I take out reclining camping lounging chairs and typically my 12-inch Meade, and we run stargazing evenings from there. But just absolutely stunning dark skies here. We also very privileged to be on the same farm as the Hess Gamma Ray Observatory. It's incredibly impressive. The CT5 telescope, which this is shown after it has been unparked for observation. The equivalent diameter of the main mirror is 29 meters. The four smaller telescopes, CT1, 2, 3, and 4, which were installed in the early 2000s, they are equivalent diameter of about 9 meters. Not dissimilar to SALT, but obviously it's an incredibly impressive facility. Currently planned to extend to 2028. They are building a new gamma ray observatory in Chile. But socially and also professional visitors, it's obviously given us quite a bit of social activity while we've been on the farm. We thought we were going to be quite isolated, but it's actually been quite busy. And a further very recent development is the Africa Millimeter Telescope, the radio telescope, which was initially planned to go on top of the Gamsberg 30 kilometers away. It looks like that is now going to be installed on the same farm as us next year. So that will also bring some activity down onto the farm for us. Just one little project that I've been involved with at the Hess site is the ROTSI telescope, which was a fast response optical telescope, 0.45 meters, which was used to support the Hess telescopes. Was shut down in 2013. But we've had a team from the South African Astronomical Observatory, more specifically David Buckley. You may recognize this person here, Willy Koorts of Sterre en Planete, and a few others, Pat van Heerden, Nick Erasmus from SAAO, that have spent some time, and we've managed to get the telescope back up and operational and being used by the African Astronomical Society. I've been involved in a number of outreach programs and public interaction with schools. The Namibia Scientific Society I'm closely involved with now as well. I had a wonderful stargazing evening for rather elite American tourists down near Sossusvlei, down in the desert. And I had a wonderful talk for Space Science Week at the DPHS in Windhoek. Very enthusiastic youngsters there. And just to close off, obviously we're living in an amazing place, not only astronomically, but on the farm, which is about 13,000 hectares. We've got free rein, and wildlife is just stunning. And we've obviously enjoyed taking people around. We've got Bushman paintings on the farm. And quite honestly, I don't think we could be, myself and my wife could be in a better place in the world at this point in time. So thank you for listening. We obviously had the wonderful comets late last year and early this year, which were an absolute treat under these dark skies. So Derek, thank you. I hope you found it of interest.
Thank you, Clyde. That was fantastic. I can assure you the audience here was riveted to the screen. And I think you're probably going to be awarded as one of the absolute highlights of our year this year. So what we'd like to do is allow questions from the audience now. But so they're going to ask from there. It won't pick up on the mic, so I'm just going to repeat it to you if you can just answer them. Any questions from this audience at the moment, or from the participants on Zoom? If you want to ask a question on Zoom, just put your hand up and I'll get you. Okay, we've got a question from David. Go ahead, David.
drives those storms and what velocity is estimated to be driving the storm?
So David's question, Clyde, is the storms on Mars. What drives those storms? What are the sort of velocities involved there? And that's basically the question. Yeah. Have you got any?
Yes. The storm systems on Mars very much driven by the obviously the winds, and again these are very much seasonal, and the winds generated very much so by the change of the seasons. We obviously see the polar caps, which grow to quite substantial size, and then during the winter's season, and then reduce down substantially. And quite often you get dust storms generated on the edge of the polar caps due to the wind movement from the cold to the warmer regions, or vice versa.
Similar to Earth weather, really. But I presume the atmosphere is fairly thin and mostly carbon dioxide, so I presume similar sort of wind speeds maybe to Earth, not very different. But I know that Jupiter is, the speeds are in thousands of kilometers. It's something incredible. That's a different story.
Yes. Yeah. Yeah, just out of interest, the Clyde spot storm initially broke out was, I think, about 3,500 to 4,000 kilometers across. But at the moment, I think that segment G is currently about 4 or 5 times the length of the Great Red Spot. So given that the Great Red Spot is about 12,000 kilometers across, that's about 60,000 kilometers in length that one storm has developed that dark belt segment. Quite amazing.
Fascinating. Amazing stuff.
The duration, the number of years that lasted, like on the red spot.
Sorry, Mick's asking about the duration of the storms. So Clyde spot, is that gone now?
Sorry?
Mick is just asking about the duration.
I'm not hearing you very well.
Sorry, can you hear me?
The duration.
Yeah. The duration of the storms on Mars.
Yeah.
The Clyde spot, is that gone now?
Well, Clyde spot has been defined as the initial storm outbreak, and it went from that cyclonic storm system to the folded filamentary region, at which stage it was still called Clyde spot. That was a year later. But once it had developed into this extended dark segment of the South Temperate Belt, now it's referred to as segment G. So segment G is actually the result of Clyde spot. So the Clyde spot refers to the initial year's development of that storm system.
Okay, we won't call it the G spot. Sorry, Elaine's got a question.
About the big spot and about Clyde spot.
Yeah.
You referred to methane, and I wanted to. Is methane easy to measure? Is it measured at different frequency? Why was it visible only in the methane?
Yeah. So Elaine's question is, why was Clyde spot clearer in the methane frequency? When you say methane, is it a filter which is just filters out the frequency that methane gets picked up? You don't have methane in your filter.
Yes. Yeah, it's the methane filters are something that's developed over a relatively short time period in planetary imaging. I would say probably it's come into its own over the last, I would say, well, 7-8 years maybe. But what because the atmosphere of Jupiter absorbs methane light, what we see is that if this feature that's high in the atmosphere of Jupiter, then that shows as lighter. So, for example, the Great Red Spot, if you look at the Jupiter with the Great Red Spot in methane wavelength, you'll see that the Great Red Spot is very bright, indicating that the top of the Great Red Spot actually extends above the upper atmosphere of Jupiter. And what happened with Clyde Spot was that this was a convective storm system, similar to a thundercloud, cumulonimbus cloud on Earth, that extends way up into the upper atmosphere, and in fact was so aggressive that it actually blew up above the normal atmosphere of Jupiter for that short time period. And that's why it was so bright in methane.
Maybe the Russians dropped a nuclear bomb there. So the red spot, that you say it's been shrinking for decades. Is it still shrinking? Does it ever sort of reverse a bit, or is it? And do they have a projection?
Well,
sort of how long it will last?
Yeah, that's a fascinating thing that we as the community are watching very, very closely. In fact, a colleague of mine in Alpo, Japan, Shinji Mizumoto, is monitoring the Great Red Spot size on a regular basis, and it's actually hit a plateau at the moment. Of course, there was serious either interest or possibly concern during the flaking events of 2019 that the Great Red Spot was going to actually disintegrate with the flaking events, but it actually stabilized, albeit at a slightly smaller size now. For me personally, it's a bit of a bittersweet subject. It would be amazing if in my lifetime I was able to observe the breakup of the Great Red Spot. But at the same time, do we actually want the Jupiter to be without the Great Red Spot? Would it ever be the same again? But if it did break up, that would be an incredible experience for I think obviously for the planetary science community, but for the amateur planetary imaging community, that would be just a remarkable event to follow.
Clyde, then just a quick question on your equipment. Do you still use that 14-inch Celestron you spoke of? Is that still your main telescope? And what are the sort of figures, your focal length and magnification you get there? Those images you showed of Mars compared to the Hubble images, to me, they look the same. It's amazing the detail you get. Can you just give us a bit of a lowdown on the stats of your equipment and so on?
Yeah, the C14 is obviously 355 millimeter diameter. It's an F11, so that gives you close to 4 meters as base focal length. But for my planetary imaging, I use a 2 times power mate. So I'm taking it up to about 8 meter focal length. And with the camera that I'm using, I'm getting an image scale of about 0.075 arc seconds per pixel. Now, that's obviously well below the theoretical resolution of the telescope, which is typically 0.332 arc seconds, the Dawes limit. But because of the type of techniques that we use for imaging, we are able to basically oversample and get the results that we're doing. Just talking about telescopes, I'll be honest, I do have a dream. If I'm in Centurion, it made no sense with the seeing conditions there to invest further in a better telescope. Where we are here, I would love to go from the 14-inch up to maybe a 20-inch telescope, but whether that will ever be within my financial means, that remains to be seen. I keep my eyes open, but yeah, for planetary, diameter is everything, size is everything for the planetary imager, purely from a resolution point of view. But that is almost secondary to the astronomical seeing conditions, because diameter doesn't help if your seeing conditions are going to be consistently below average or poor. What I can say is that where we are in Namibia, I believe I can honestly say that the seeing conditions here are better than in Centurion. Certainly not perfect, but still I have no hesitation in saying that we made a good move.
I'm pretty sure Martin Lyons has got a couple of 20-inch mirrors in his house in Somerset West. I've seen them. Maybe you can ask him. That's something.
I'm in discussion with Martin.
Maybe one of those rich American tourists can donate a plane wave telescope 1 week or something for you. But those are like a couple of $1 million. So yeah, we can only dream. Anybody from the Zoom clientele that would like to ask a question? We've got Chris Stewart. Any questions? Art Bonkerman, Dion Krieger, Peter Kogel, Pat. Put your mics on and ask a question.
No question, but I thank you, Clyde, for a very interesting talk.
Go ahead, Chris.
Good to see you, Chris.
I said I don't have any questions, but I'd just like to thank Clyde for an interesting talk.
Okay, thanks, Chris. Great, yeah. All right, if there are no more questions, then thanks very much to everybody for their attendance, and thanks for a fantastic talk, Clyde. I hope we can do this again sometime in the future. Sorry, one more question. Elaine wants to know if your comet photograph is real. Just remind us which comet that is again.
Yeah, that was the one with the, I think the difficult name. Is it Tuchennamen or something? Okay. It was in October 2023. It was yeah, I must be honest, not the greatest comet photographer, but yeah, tending to spend a little bit more time now under the dark skies, and yeah, hopefully in the future they'll be a bit better. But it was just amazing. There was the one earlier this year as well, and we spent quite a few evenings just out more with binoculars and just observing visually. Absolutely stunning.
Yeah, great. And I've actually been to that Hess telescope before myself, and I found it quite amazing. Yeah. So maybe I'll pitch up there and come and shake your hand there at your observatory sometime again in the future.
You'd be more than welcome, Derek.
Okay, great. Thanks very much, Clyde, for the effort, and it's fantastic.
Great.
Right spots.
All right. We'll be in touch.
Okay, thanks very much, Clyde.
Okay. Let me stop the share.
Okay, the guys on Zoom, we can't allow this.
Yeah. All right, Derek. See you guys.
Okay. Bye.